Hey guys, welcome back to the coding part of this video. So in the previous video, we have learned about random forest, the benefits of it and the drawbacks. So now we're going to do the coding. In this project, we need to evaluate the car acceptability using the two methods in random forest classifier. It's the bagging and the feature randomness. So here, buying price, maintenance cost, number of doors, number of persons, lugwood, and safety are independent variables. And decision or class, unique, act, good, or vigor is an independent variable. So after completing this activity, we will have a good understanding of random forest classifier and how to do the feature selection. So you guys open your Jupyter Collab, your Jupyter notebooks, or your Google Collab notebook, and we're going to get started. Now, we're going to import the libraries. What library are we going to import? Yes, it's the Pandas library. Now, we're going to read the data. We're going to create a variable, data is equal to pd.read underscore csv. We're going to have the brackets and inverted commas, and now we're going to paste our link. And remember, the header should be none. Now we're going to rename the column name. So the column name, buying, maintenance, the doors, persons, lugboot, safety, and class. So data.columns is equal to column names. We're going to check the info or rename them. Now we are going to perform the EDA, the exploratory data analysis. In that, we'll print the top 5 rows, the height and the dimension, the information, the check if there are any missing values, and if there are any missing values, how much, the information of every column, and the types of data. Now we're going to explore the class variable. What do you say? Go deeper into it. Now we're going to check data using the value counts. And after you're done running it, this will be our data set. Now we're going to do the feature selection. So x is equal to data.drop class. X is 1. So we want to drop class from x, and instead we want to place it in y. Now we're going to import the libraries. Import category encoders as CE. Well, this is not in default whether you're doing it on Google Colab or Jupyter. For Jupyter, you will have to download it, but for Google Colab users, you will have to write !pip install category encoders. And then when you run this code, then it will work. So now we're going to encode the categorical variables into the ordinal encoding. The categorical variables are buying, maintenance, and doors, with the ordinal encoding means to convert them into zeros and ones. So after we're done with this code, we're going to we are commanding encoder to fit and transform x. Store some of the variables inside x so we can predict it better way. And now encoder is equal to ce.ordinal encoder columns class. What this line is gonna do, it's gonna like what we say do it. Now we're going to do the same for y. We're commanding encoder to fit and transform y so we can predict it better. We're going to import the library which splits the train data and the test data, which is the sklearn model selection import the train test split. Now we're going to split into training data and testing data. So xtrain, xtest, ytrain and ytest will all be equal to train test split x and y, and we're going to keep the test size 0.33 and the random state is going to be 42. Now we're going to we're going to train the random forest with default parameters. Means we're going to import the random forest classifier. So from sklearn.ensemble, import the random forest classifier. We're going to create a variable which is going to be rfc1, which is equal to random forest classifier, and no random values popping out here. We're going to fit the model. So we're commanding random forest classifier to fit x train and y train, so we can predict it in a better way. Now we're going to predict the test set result. So we're going to create a variable ypred, which is going to be predict x test. So we're predicting the test set results. Now we're going to print ypred. Now we're going to check the accuracy score. Which variable is used for the accuracy score? Sorry, library. Yes, good job. Is from sklearn.metrics, import the accuracy score. We're going to train the random forest with an estimator of 300 parameters. So the model accuracy score with 10 decision trees is we're going to check the accuracy score with y-test and ypred of the decision trees. We're going to do the same, import the random forest classifier, store it in a new variable, and n estimator is equal to 300 random state 0. We're going to fit x train and y train again. We're going to predict x set again, and we're going to import the sklearn.metrics accuracy score again. Now, the model with 200 decision trees is, well, it's the accuracy score of y-test and ypred with the decision trees. Now moving on to our next step. So we did this in the up. Now we're going to load the random forest classifier and train it. So we're going to create a new variable, CLF. So random forest classifier estimator is 300 and random state 0. We're going to fit x train and y train, and we're going to calculate the feature importance. So feature scores is pd.series random forest means CLF cliff dot feature importance index x chain column. So what are we going to do? What are we doing here? We're calculating, and the ascending is false. Now we're going to print the feature scores. Now we're going to print the x and y column. So data.drop is data.drop class and doors axis 1, and from y recollect the class. So we're asking x to drop class and door, and y to get class from x, like buying and selling. Now we're going to import the library and doing the transformation. We're going to import the category encoders. We're going to do the encoding of buying, main, person, lug, boot, and safety. We're going to fit and transform x, and we're also going to fit and transform y. Now we're going to import the library again and train again with the updated x and y. We're going to do the same thing here. Import the model selection, train test, then x train, x test, y train, and y test is equal to train test split, x y, and the test side is 0.30, and the random state is 0.42. 42. Now we're going to import the random forest, which is from sklearn.ensemble, import random forest classifier. RFC3 is going to be our variable this time. The n estimators will be 300, and as you know, random state is going to be 0. Now we're going to predict for the x test values. So ypred is equal to RFC3 predict the x test. We're going to calculate the accuracy of the model. So sklearn.metrics imported and accuracy score. Now the model accuracy score with 300 decision trees is the accuracy score of y-test, ypred, and the decision tree. So We have safety is 29, presence is 23, buying is 16. So this is all what you say the value. And I've noticed one thing. So the moral accuracy score with 10 decision trees is 96. The moral accuracy score with 200 decision trees is 96 8. So 968, like this is 96 and this is also 96, you can say. And now the accuracy score with 300 decision trees is 94. Can you tell me why is there a difference? I mean, I know you would have thought that 300 decision trees is going to be better than 210. But the thing is, when there are more decision trees, it's a bit of what we say overfitting or oversizing. That's why the computer gets a bit confused and it gives us a lower result. So, and if we have a 10 decision tree, it's not that enough to predict something. So the right one is 200 and decision tree. 200 decision trees. So guys, thank you so much for watching this coding video. So don't forget to like, subscribe, hit the bell button and share it with your family and friends. Don't worry, I'm gonna do something else sooner because my exams are about to end in just 2 more days. So then I have winter vacations and I'll be able to do whatever I want. And thank you so much for watching this again. And I'll see you next time. Bye.